Here in this section, I will use two more examples to demonstrate how for the topic, the type 3 indeterminate problems, which means gears, the shaft coupled with gears. The first one, the statement is this. Here that is two, the gears can be coupled with the shaft, and here is our input. So this is our given one. We're given certain torque here, and in certain way, the TF should be provided in the way to get everything in static equilibrium. So you might imagine the F here simply is a wall, and then the wall basically there to get everything static in equilibrium here. Okay, so by removing the constraint of the wall, and that replaced it by certain reaction. So here is our driving, that is our driving, and then simply that's a counterbalance. And for this problem here, assuming you can imagine simply replace this as by a wall here. Okay, so for this problems we are given, we wish the allowable stress is less than 7,000 psi. So that means for we want to determine, based upon this criteria and all the dimension here, we want to determine what is the maximum, what is the maximum torque that's allowed to apply here to have ensure the maximum stress in here and here is less than or equal to the allowable, that is 7,000 psi. Okay, so that is our design criteria. So now let's check the shaft BC. So we check one by one. So in shaft BC, the maximums, we know that is TR over J, okay? And so here the T, because we're looking for maximum, so here I simply replace by his diameter C here, okay? So that is everything pertaining shaft BC here, and this one is less than required by the design criteria, less than equal to 7,000. So here we have information. So T in shaft BC. So right now I try to extract the individual terms for shaft BC. Okay, so T for shaft BC here, basically that is our input torque here. Okay, so that is the torque here, and C is our radius. So here the shaft BC equal to 0.6 diameter, so that's a 0.8. Okay, and J equal to pi over 2 C to the fourth power here. So we put everything in calculated, then here we should be able to determine TC is less than or equal to 5630 and pound per inch. Okay, now we check the shaft EF. So basically right now I'm checking this one here. So the same thing, sorry. The EF, the maximum, and again is TC over J, and everything here is pertaining to the shaft EF information and less than or equal to 7,000 psi. So here we can check, and so T in shaft EF, so T equal to the torsion in shaft EF. And again here I have this formula remind you, basically in EF that simply is equal to the for this case, let me translate it here. Okay, so this is what we're looking for, and this is our input TC here, and this is gear B. Sorry. And this is this is our gear A, okay, and this is our gear D. So this is RD and this is RA. Okay, so that's the symbol here. So that one basically equal to RD and RA and times TC. Okay, Okay, so basically here from this one is 2.5 divided by 4 times TC, that is 0.625 TC here, okay? And here the C is the radius of the shaft EF, and that is 1.25 divided by 2, that is 0.625. 0.6 0.6 I think 0.625, yes, okay. And then the J equal to pi over 2 and to the 6th for the power, so that is pi over 2 and 0.625 to the fourth power. So everything together, then we can solve for, in this way, TC is less than equal to 4,300 pound-inch. Okay, so after we check the both shaft, and we know the TC must be less than equal to this number, as well as TC must be less than equal to this number. So the overall, our answer, the TC, to satisfy both shaft, the TC must be less than equal to this one. Okay, because once this is satisfied, then the shaft CF, the EF will be satisfied, then this one will be satisfied as well. If you would choose this one, then if you would choose the larger one, then you can see the larger one, say for example 5,000. 5,000 going to violate this one. So under this situation, you should pick is the domain, the smaller one here. Okay. So that is a detailed calculation for your reference. And we can look at the second example here. And this one, basically, we have applied torque here, and through this kind of dimensions, and we have two design criteria. We have to satisfy both. Okay. And so basically, one is the maximum stress is the allowable is 60 MPa, and also we want to make sure the angle of rotation at D here is less than 1.5 degrees. Under these situations, we want to determine for both shaft, they made of the same dimensions. We want to determine what is the diameter. Okay. So for this case, we simply check, and let me do this one first. So the maximum stress, and basically the maximum stress I'm going to check is both shaft here. So say for example here the C, let me do this one, CD less than or equal to 60 MPa. So let me check this first. Okay, so here the tau CD, we know that is T, and maximum is TC and over J. Okay, so that is for shaft CD. So for this case, we know the T for shaft CD basically equal to what we are given here, 1,000 Newton meters. Okay, and C is the radius we're looking for. And J equal to pi over 2 C to the fourth power. So basically from these conditions, then we can obtain is the C must be greater than equal to 111.9 millimeter. Okay, so now we check the tau AB, and less than equal to 60 MPa. So tau AB, again, we're looking for the maximum value, so TC over J, and everything pertaining to shaft AB here. So in this case, the torsions in AB equal to how much? And again, here we come to our formula of the gear, the transmission. So that is the radius of RB here, radius of gear B divided by the radius of gear C, and multiply with the torque corresponding. So that is T there. Okay. So basically here, if you remember again, so that is our shaft here, and here is our torque, and this is the RB, and this is our RC, and this is the RB, and this is looking for here. Okay, so record this one, so we have this one here. So basically from here is 2500 Newton meters, and C is the number we're looking for, and J equal to pi over 2 C to the first power. So under these situations, then we can find the C must be solving for meet this criteria, this be greater than or equal to 29.8 millimeters. Okay, then we're going to check this criteria here. Okay, so to ensure the angle of rotation at D less than or equal to 1.5 degrees, and we record this one. Phi D, we can say take the relative displacement concept, the relative to C. Okay, this the relative to C here, and then but we know the C is also rotated by through the gears, so that's a C here. Okay, so this one we know that must be less than 1.5 degrees, and 1.5 degrees is 0.026 radian. Okay, radian. Okay, so now we individually we look into these calculations. The first one, what is phi CD? So phi D over C basically is the relative, the angle of the twist in shaft CD, so that is TL over GJ using this information here. Okay, so in these informations, and the T equal to the torsion, the torsion in the shaft CD, so that is 1000. That exactly is where we applied here. Okay, and L is the length, and the length equal to 600 millimeter, 0.6 meter. The length of the shaft, and G is given, and J equal to pi over 2 C to the first power. C is determined. Okay, so now what is phi C here? Phi C again, phi C is the angle of rotations, and so phi C is this one. So this is the gear C, so this is the gear B. Okay, so this is the radius RB, this is the radius RC here. Okay, so here the angle of rotation is this one. So from here you can see this is the phi C, and so this is the phi B here. Okay, so from here you can see the phi C times RC equal to phi B times RB. So therefore phi C equal to phi B and RB and RC. So what is RB? RB equal to 100, RC equal to 40 times phi B here. So basically that is equal to 2.5 phi B. Okay, so here let me translate that information to here. So this one equal to 2.5 phi B. So what is phi B? Phi B again, this one phi B equal to phi B relative to A plus phi A and phi A. Okay, and A is fixed against the wall, so this number equal to 0. Okay, so now what is phi AB? Phi AB basically is the TL over GJ and everything pertaining to the shaft AB here. Okay, so phi AB equal to this one. So that one you can see basically in information the torsion in shaft AB, and we have determined earlier, so that is here 2500. Okay, and L is the shaft length, and that is 400 millimeters, 0.4 meters, and G is the material properties, and J the same thing. J is this number because the both shafts have the same this one. So put everything together to solve for, then here we should be able to find it is C must be greater than or equal to 31.4 millimeter. Okay, so here you need to take a little bit time to implement the whole calculation here. So now compared to right now how many we have such a result. C must be greater than equal to 11, almost 12, and greater than 29.8, greater than 31.4. So here is our number, our result. So The C, the minimum required diameter should be equal to 31. The radius 31.4 millimeter. So our answer is 62.8. Okay, and so this page is the detailed calculations for your reference.